Now the fourth problem, finding L inverse of 5s plus 3 divided by s minus 1 into s square plus 2s plus 5. Now I'll split this function as 5s plus 3 by s minus 1 into s square plus 2s plus 5 equal to a divided by s minus 1 plus bs plus c divided by s square plus 2s plus 5. Taking LCM on the right side, I write this as 5s plus 3 divided by s minus 1 into s square plus 2s plus 5 is equal to a into s square plus 2s plus 5 plus bs plus c into s minus 1 the whole divided by s minus 1 into s square plus 2s plus 5. Cancelling the denominators, I write 5s plus 3 equal to a into s square plus 2s plus 5 plus, I will multiply these two terms, bs square minus bs plus cs minus c. And now I need to find the values of the constants a, b and c. To do that, first let us give the value of s as 0. If s is equal to 0, I get 3 equal to 5a and s is 0, so all these three terms are 0. Next I have minus c. So 5a minus c is equal to 3. Next what I'll do is I'll give the value of s as 1. If I give s as 1, I get 5 plus 3 which is 8 equal to a into 1 plus 2 plus 5. If I give s as 1, all these terms becomes 0. So if I substitute 1, this 1 minus 1 becomes 0. So the whole terms becomes 0 here. And so I'll write this as 8a equal to 8 and a is equal to 1. Next, I'll substitute the value of a here and I'll write 5a minus c is equal to 3, which implies 5 minus 3 equal to c, or that implies c equal to 2. So I have got the value of a and c. Next I need to get the value of b, for which I will compare the coefficient of s square. Equating coefficient of s square on both sides. On the left it is 0 and on the right it is a plus b. So this will imply b is negative of a, which implies b is minus 1. So I will substitute a, b and c values and then find the inverse Laplace. So 5s plus 3 divided by s minus 1 into s square plus 2s plus 5 is equal to 1 by s minus 1 plus b value is minus 1, so minus s, plus 2 divided by s square plus 2s plus 5. Applying inverse Laplace on both sides, we write this as L inverse of 5s plus 3 divided by s minus 1 into s square plus 2s plus 5 is equal to inverse Laplace of 1 by s minus 1. Applying inverse Laplace for the terms individually, minus L inverse of s divided by s square plus 2s plus 5 plus 2 times L inverse of 1 by s square plus 2s plus 5. Next, L inverse of 1 by s minus a. So this is e power t minus. The denominator is a quadratic. I need to make it a perfect square. So I will write L inverse of s divided by s plus 1 the whole square minus 1 plus 5. Likewise for the next term 2. 1 by s plus 1 the whole square minus 1 plus 5. So this can be written as e power t minus L inverse of s divided by s plus 1 the whole square. 5 minus 1 is plus 4 plus 2 times L inverse of 1 divided by s plus 1 the whole square plus 4. Now I have told you the numerator is s and the denominator is s plus 1. We need to make both same. So what I will do is I will add and I will subtract a 1 in the numerator so that I will get both numerator and denominator in the same form. So in the next step I will add and I will subtract a 1. So this will make it equal to e power t minus L inverse of s plus 1 minus 1 divided by s plus 1 the whole square plus 4, was the bracket, plus 2 times L inverse of 1 divided by s plus 1 the whole square plus 4. I'll again split this term, e power t minus L inverse of s plus 1 divided by s plus 1 the whole square plus 4. Minus of minus makes it plus 1, L inverse of 1 by s plus 1 the whole square plus 4 plus 2 times L inverse of 1 by s plus 1 the whole square plus 4. These two terms are the same, so I can write 2 plus 1, it's 3 times of the same term. So this is equal to e power t minus, if I apply the inverse Laplace for this term, s plus 1, so the variable s has been shifted. I will write this as e power minus t L inverse of s by s square plus 4. And adding these two terms, I will write 3 times. And the variable s has been shifted, so it is e power minus t L inverse of 1 by s square plus 4. The next step, e power t minus e power minus t s by s square plus a square. Here a takes the value 2, so this gives cos 2t plus 3 times e power minus t, a by s square plus a square. Here that a is not there, so I need to divide that by a, where a is 2, and this is sine 2t. So this completes the next problem, fourth problem.